concepts. And specifically, we're going to be going over object-oriented programming. That's something that you might have heard while you were learning about JavaScript, because JavaScript certainly has a lot of object-oriented programming principles baked into the language. But we are going to, over this week, go over the fundamentals of object-oriented programming. What does it mean what is a programming paradigm to begin with? What are the features of object-oriented programming? Why do we care about it? And how can we use object-oriented programming to solve all sorts of different problems, and how we can use OOP, is what it's called in short, to create maintainable code that, and specifically maintainable and reusable code that we can build applications with faster. Cool. So hopefully people didn't have too much trouble with the previous week's content, and we're able to go through all of the parts of the project and got to the classes, because we're definitely going to be using the Midwesterners, oops, oop. Yeah, we'll definitely be using classes a lot for this week. And hopefully at the end of this week, we will understand how to use classes specifically, and how to organize programs using classes, and create different instances of objects with them, and can hopefully find and understand when it is best to use OOP. Cool. So let's just get started with first going over kind of what is object-oriented programming, and sort of what is the thought process of when we would want to use it. So object-oriented programming is a way for us to use objects to describe a problem. And objects in object-oriented programming kind of have two functions. They can store information about themselves, and they can also have these sort of verb. So they can have functions that describe how objects interact with each other. And I think the best thing to do is actually start with an example of what an object might be. So let's say we were to design a car catalog or something like that, or maybe a video game, and one of the objects in the video game could be a car. So we could go ahead and create this object called a car. And this, we can call it a class. And a class and a class can have two things associated with it. It can have properties or attributes. And this, for a car, can anyone give me examples of what an attribute for a car might be? Yeah, color, engine, definitely. Maybe make, model. Yeah, cost, all that kind of stuff. Yeah, definitely kind of all the different stats of this car. And we can also have functions. And so these, if the car is the noun, so we have a car, and it might be some kind of ambiguous thing. We might define the make and model and all of this other stuff later. These could be sort of the adjectives that describe it. Adjectives. And we can also have functions, which could be kind of like interpreted as the nouns of, the verbs of the car. So what kind of functions might we want to have for a car? Yeah, drive, definitely. Can have drive. Stop. Stop's really good if a car can do that. Turn, for sure. Maybe play radio or something like that. I don't know. All kinds of different things. Yeah, horn. And so these, we just kind of described all the different, or a lot of different functions that we understand that a car might have. But what's really good is when we organize our code this way and we have a class for a car, we can then also take this object and create specific type of cars. Maybe we want to have a four-wheel drive car, right? Or maybe we can have a rear-wheel drive or a convertible. And when we create a base class for a car, we can then have ways to extend it into different types of cars that might have different functions. So 4x4 might have a drive, stop, turn, and radio, but it might also have engage 4x4 or lock up the wheels or something like that. And a convertible can have a drop the roof up the top. And with this, when we organize, let's say we're making a video game or we're making a car catalog, with this way, instead of having to define all of these attributes for all of these classes, these would be other classes, but we could extend them from a car. And with this, we can sort of see where the power of object-oriented programming comes. We have a car and it might interact with other objects. It might have its own objects in it. Maybe it'll have passengers, or maybe it'll have an owner, or some other kind of object that might have its own attributes. And we can also create other objects very easily by extending this car and sort of making the 4x4 convertible a car with extra stuff. Cool. Great. Any questions on that? Okay, so I think best is we just get straight into coding and actually coding up some of these classes. So for the example, let me just share the code. So let's say, for example, we want to create a program that gives us a catalog of a department store. So kind of like when you go to a department store and you want to go and use one of those terminals that tells you where different departments are, we're going to kind of code a user interface with that. And we're going to go through all of the flashy parts. We're going to write a few classes. We're also going to write some user input. We're going to process error handling. And in the end, we're going to have an application that will actually be able to tell us, hey, if I want to shop for clothes, which floor would I go to, or something like that. And specifically, we're also going to use object-oriented programming to make this extensible and for us to be able to kind of create all kinds of stores. Because what if we wanted to sell this to Macy's, but then also like Bloomingdale's, and they have different floors of different things. So we definitely want to create some code that will allow us to sort of reuse all of these different classes that we're going to write. So maybe the name of the file is a bit of a giveaway, but what is maybe the first object or one of the objects that we want to define for a problem like this? Yeah, we definitely want to have a store. So let's say we're going to end up having a store. And let's say we want to keep track of a few properties of this. And for now, let's just only keep track of something like name. And we can also keep track of categories. So in this case, categories would be kind of like department categories. And we can also make categories its own object, because then categories can have its own properties. What kind of properties might we want to keep track of for a category class? Yeah, so Layla said type. That's definitely a good property that we might want to have. Type, maybe like the name of it, or and I think Emily and Ashley, you guys gave examples of type, right? So we would want to keep this as generic as possible, and then at some point we might want to define the electronics category, or the electronics clothing, or sorry, the clothing category. Right, but this way we keep it generic. We can reuse a bunch of code that's related to category like electronics, category like clothing. They probably will want to have like an address or location in the store. Maybe they'll have some features in the store, like maybe the walls are painted a different color in each section or something like that. But the point is that they're still going to have common adjectives to describe them. Cool. So I think that, oh yeah, sorry, someone wants to speak something? Yeah, sorry, I thought I heard a microphone. Cool. So let's just go and create the first class. So in our case, we want to create a class store. And in Python, all we have to do to create that is just write class store. In JavaScript, there's also object-oriented programming, but it's done more on something called prototypes, which are kind of like templates. So really, when we're creating this class store, think of it as like we're creating a blueprint for a store, and it could be any kind of store that has these properties. But we are not defining that this store has to be like the Gap yet or anything. And when we actually want to create this class, how do we actually create, what function do we need to create an instance of a store and give it in all of its properties? Yeah, awesome. You guys are on top of it. We definitely need an init class. So in Python, a init class is built with these two underscores. And the first property is always going to be self. And then we can add all kinds of different properties that we want. We thought let's just keep track of name and categories. And then if we want to actually set the store property, the instance of the property's name, we want to do self.name equals name, and self.categories equals categories. Now, could someone explain what is the significance of self in this case? Yeah, you guys are all nailing it. So self will refer to the instance of a store when we actually go ahead and create it. So when we go ahead and create the store with new store, and we or I guess in Python we just do store, and we actually write the name Macy's or something. And categories, self will relate to that specific instance of the object. Cool. And let's say that we know we're most likely going to be selling this to one store in particular. How can we make name? And yeah, Henry, it's right. It's basically like this in React. Yeah. Or in JavaScript, you would use this dot name, this dot categories. If we wanted to make name or categories an optional parameter, so we didn't actually always have to keep passing it in, how could we do that? So let's say we always sell to Macy's, so we could just name it always Macy's, and then we could reuse with a different name. Yeah, we can use the default params. Cool. So now let's actually write some code that will run in our application that will then ask, it'll create an instance of the store, and it will also allow the user to ask, hey, here's the store, what category you're looking for, and then maybe we can print out some information about the category later. So first, let's find out that we created this correctly, and let's instantiate an example of a store. And so let's say, let's get rid of name equals Macy's for now, and then we'll say the dugout. And categories can be an array of running, baseball, basketball. So we're making a sports department store. And let's try and print my store. And let's first find out what is going to happen. Cool. So we ran it, and it printed down here. Let me try that one more time. And that doesn't really give us anything useful, because what print does when it takes an object is it actually sees that it's got some kind of object that it's trying to print, and it's actually going to look for its dot underscore underscore stir class, and it's going to print whatever that function returns. So we don't actually have that defined, so it's just going to print the default address, location, memory for this class, and that's not really interesting. So if we wanted to be able to print an instance of my store and actually have it output something interesting, in Python we can overwrite this stir function and actually have it return a specific output that then can be consumed by something like print, which will then print whatever it is that we want. So let's say that we want like a welcome. Every time you print the store, we want to have kind of like a welcome to this store. Here are the categories. So we'll start with an output variable, and we can build this output string. So at the beginning, we could say self.name, and maybe let's add a new line to that. And let's go ahead and print out all of the different categories. So self.name, because we are using self and we're actually passing self as the first parameter of this function, we can have access to the instance of this object. And that way we know what the name value is. So we can go ahead and do something like this. So let's print out all of the objects or all the categories in order. So for C in self.categories, let's add to output C.name, or no, I guess in this case it would just be C for now, and add a new line, and go ahead and return this output. And let's find out if we got this right. Here we say the dugout. Maybe we can say something a little bit like welcome to dugout. And maybe we can also print these in order. So we can do something like this, I plus equals 1. And we could do I or stir I plus. Cool. And so if we run this, nice, we can have these categories. So now this is how we can have Python automatically know how to print whatever it is we want about our object. By defining this built-in kind of function that every class automatically comes with, we're basically overwriting what the default function would be, which is just print the address in memory, and we get this weird, very unhelpful statement. And this way we can actually get something a little more interesting out of it. Cool. So any questions so far about what we've just done? What is I for here? I'm just using I just so that I could have these numbered over here. so that right now, the next step is we're going to actually ask somebody which category would they like to know more info about. We can have them pass in number 1, 2, or 3. But basically just to make this output look a little bit prettier. So we're just using it over here. There's potentially more other ways to get my store info printed. We can have a function on the class itself. But if we wanted to use it with print just expects a class object to have this, this stir defined. And it will print whatever, it'll call it and will then print whatever stir has. Why start output is set to this? Well, when we create a variable in Python, we can't just not instantiate it to anything. We could set it to null or I guess what is null in Python? Null like this. We have to set it to something. None. Thank you. That's what it is. Yeah, we could set it to none, I guess. But just to define it as an empty string. We could also just do this. Like this will be fine too. Cool. All right. So now this program gives us info about a store object we created and some categories. If we wanted to create a second store, all we would have to do is, let's say my grocery store, and we want to call it Foodland. And we can now have different categories, meat, dairy, produce. And just like that, we have already created a whole new different object with a whole different output by just being able to reuse this class. So if we were selling it to both the Dugout and Foodland, our demo app would have one instance of this, one instance of that, but we would not have to actually rewrite any code, and we wouldn't have to go ahead and hard code these strings. And sort of that's where the power of classes comes in. Cool. So let's make this app a little bit more interesting. Let's make it a little more interactive and actually have users be able to ask, hey, what's going on with the running section, or where can I find baseball equipment? Ashley, you asked why is the structure like this? So this is exactly what our init function expects minus the self. So the self is kind of built in. All class functions will have a self, and we don't actually have to pass that. It gets implicitly passed in when we call any function on a class object. But here, the name will be the Dugout. Categories will be this array. If we had another variable like address, we would have to pass another parameter in. And we really wouldn't be able to use a class without defining an init. It wouldn't really be a useful class at all, because we wouldn't actually be able to call the class as like a function like this and create an actual instance. So we definitely always want to have an init. Andrew, you asked, can it be anything for categories, string, array, object? Yeah, definitely. I kind of made the call for now to just keep it a list, but in very short time, we'll actually make categories another class. And Arpita, you asked, are we overriding stir? Essentially, yeah, you could say we're overriding stir, because technically stir, I believe, does exist. we're technically overriding init as well, in a way. These are sort of built-in functions on top. It's the technical term for it is oh, what is that? I forget, I'm blanking out, but you're able to overwrite built-in functions for classes. Overloading is what it's called. So you can even overload operators. I won't go too far into it, but you can pretty much overload anything like the plus sign if you wanted to create an array or a class that could be used in this object plus something else. You technically could overwrite the operator for that. You can overwrite pretty much anything. Yeah, but so we're basically just overloading the stir function. Yeah. So yeah, if you guys go ahead and want to look up what overloading is, you can find that you can pretty much overload all kinds of different things. And so if you did ever have a reason to do my store plus, I don't know, a new category, if you ever wanted to like do like football, you technically could do this by overriding the def iad function. But we won't get into that. Okay, cool. So let's move on to actually making this interactive. And I believe in the project you guys just did last week, we went over how we could use the input function to get the user to input something in the console and have us receive that variable. So let's say we want to have the user select the number of the department, and then we'll give them a little bit more info on that department. So let's call it selection, and we can do input. Select the number of a department. So now if we print the user selected selection, we should be able to see this work properly. Let's double check. Select the number 2. Cool, the user selected 2. Okay, cool. So let's actually do something a little bit more interesting with that. And we could do, maybe we can actually print, instead of just printing the selection that they have, let's actually go ahead and print my store dot categories, categories selection. Probably want to do selection of -1 because we're allowing them to, we're starting our numbers with 1, but obviously lists start at 0. So if we do something like 2, oh yeah, that always gets me. Cool, the user selected baseball. Right, so again, if we did have our other department store and with more other options, we could obviously automatically create this little program that outputs different things based on just one line that we have to change, which is defining a new store variable. So now we're getting somewhere. Now we're getting a little bit of user input. Let's make this user input, let's keep looping so that our program doesn't terminate all the time when we get the first input. So let's do something like this. While selection doesn't equal the length of the categories that we have, +1. We can keep asking, let's move this over here. So now if they don't select anything, doesn't equal, I'm not actually sure why my code, looking at my notes, I'm not so sure why we're doing it this way actually. We want to double check that someone doesn't select anything wrong, basically. Oh, right. Let's also give them another option over here. So let's also do something like this. So output plus equals, I just missed this one line. So stir at I, let's give them the option to also type in like number 4 or another number to then to quit. Cool. So now if they select something like 4, it'll quit. Right now, obviously, we're gonna have a couple of issues with our code, but essentially, if selection ends up being the length of categories plus 1, we will terminate the loop, essentially. But now, if we do input the correct input, selected running, selected baseball, selected basketball, we can go back to running again. So cool. So we have a bit of a loop. We just need to get this for to work properly. We can do something like if selection. Okay, yeah, so we can just do something like if selection equals the length of my store categories plus 1, we can just go ahead and break out of this. Maybe we can print thank you for shopping and get out of this selection. So let's try that out. Oh no, what am I getting wrong? Oh. Cool. I always get caught up with the fact that input is going to be a string, and we have to make sure we're casting everything in Python properly, or these comparisons aren't going to work as well as we want. Cool. So otherwise, we can also go ahead and print which department. So what other inputs do we want to make sure we are checking that they don't input so that they don't break our application? Yeah, letters, strings for sure. This will definitely break, and we'll get a value error because we're casting things into integers here, and obviously that is going to break. And yeah, any value that's not listed. So we definitely want to check that if it is a number, we want to make sure that the selection is within the range. So let's just do that. Int selection. In fact, maybe we can do something like this here. Selection equals int selection, so we don't have to keep repeating ourselves, and we can move this over. So now we know for sure that it's already an integer. So we want to make sure it's greater than 0, and we want to make sure that selection is less than or equal to the length of my store dot categories. And in this case, we also don't need this. Cool. So we just tested for this. And now if, and then here we can write else. please print, we'll print, please select a valid category. So let's say 5, please select a valid category. Quit will still work. 1 will still give us all what we want. 100 will still be, or 1,000, 10,000 still gonna be that. And if we type in, if we enter a letter, we are going to get an error. Now, can someone tell me why we're getting this error? I guess I already said, but what can we do in our code to make us, how should we handle this situation? Yeah, so we get a value error in this case. That's what this line 24 returns, as Brett mentioned. So how can we gracefully handle this error, knowing that we will always be getting this error? We could maybe handle it in some way. Yeah, for sure. We should definitely wrap it in the try except, and that way when we get a value error, we know why we got it, and we can print out an appropriate response. So let's put all of this into our try, and our except will just look at the value error. So my IDE is autocorrecting correctly. So please enter your choice as a number. Cool. So if we try this now, oh no. Oh, right, whoops, because I'm supposed to put this, the important line into the try. Yes, so yeah, Brett, sorry, I didn't even see your comment yet as I was writing it, but definitely. What is happening now? Oh, over here is where it also causes issues because it goes back to the loop. So I think we can get rid of that, and I think we should be able to now. There we go. Perfect. So what was happening is this was already cast as an integer, and it was double checking and crashing. Cool. And so if I type in 4, we'll quit. If I type in 1, we'll get running, 2, basketball, and so on and so forth. Perfect. So now we have a bit of a more fun application where we can actually ask users for input, and we are also casting, we're also making sure that we're checking user input errors. Yeah, Brett. To be honest, I don't think it was cast as an integer automatically at that point, because I'm not fully sure. I guess yeah, at that point, I think the selection is now, yeah, it's now whatever this value is. So it was cast to an integer. Yeah. So at this point, it's already an int. But if it didn't, if it crashed, then it would still be whatever it was before, and this condition is still not true. So we're still comparing a string to a length or to an integer, and the condition still isn't true. We pretty much could just write while true, to be honest, in this, because I don't actually think it super matters what we have here. But essentially, at this point, a string does not equal the length of categories plus 1. So it returns false, and we get back into the loop. Cool. So at this point, we have a store. We have a way to print something out of it, and we also have a way of creating a different store with different categories. But right now, the fact that we get the user selected baseball isn't really super cool. We probably could make this a little bit better if categories themselves were classes. So I think that at this point, we should definitely start creating a different class for categories. And so the nice thing about the way we want to organize this code is we can extract the categories into a different file and then import it in here. And that way our files represent our different types of objects that we have in the program, and we could kind of organize our entire application file system based on that. So we can call this category. I already have a category, but I'm just going to delete that real quick and create a new one. Category.py. And here we want to create a class called category. And we again want to make sure we have an init, and we want to have a self. And let's say we want to just start off with the name for the time being. And then we definitely want to add more things to categories in the future, but this seems like a good starting point. Cool, and we also want to be able to print this, so we can also go ahead and overload the string, the stir method. And let's say for the time, let's say that people want to learn about products for a category, and at some point we will also add the product class, and maybe we can have a list of products that each category carries. But right now, let's just say no products available. We're going to have a very sparse store in self.name. Cool. So now when we print a category, it'll return us this string. Now we can go ahead and import this file. So from category, import category. Now we have this other class that we can use here instead. So instead of running baseball, basketball, we can go ahead and instantiate each of these the same way we did with store. So category running, category baseball, and category basketball. And so now instead of, actually, let's see, I think this might automatically work. Oops, can't open file. Did I run something wrong? Right. So C is no longer a category in this case. So we want to definitely change this code so that we're no longer, because we want to do C.name. And see, cool. So we still have the names printed out, but now it is stored within an object. So category is also an object, and running is no longer just C. It's the name of the category that we actually have. And so now if we go ahead and print running, cool. We actually want to go ahead and change this. I was kind of hoping that because we have print in here, it would automatically work, but that's not totally right. So now we can just go ahead and print the actual category that we have, and it'll call the stir function of that category for us. So when we go ahead and print baseball, it'll say no products available in baseball, no products available in running, and to no surprise, no products available in basketball either. Cool. So at this point, we now have created an application where we can have this reusable class store. We've also been able to create a whole different file with that stores a different category. And we can also go ahead and extend that to have more interesting functions and be able to store more interesting properties and whatnot. But we didn't have to go ahead and recreate a category for basketball, a category for running, because they all share the same common methods. And this way, we're able to kind of define a relationship between a store, between categories, and be able to organize our code this way so that we could go ahead and reuse them. Yeah, and definitely. So Brett, you said, could you go over how categories class comes into the store class? For sure. So the way we define this relationship between a store and categories is one store can have a list of many different categories, for example. And right here, when we call category running, we create a new object that has the name running. And in the future, if it has more properties, we can go ahead and add more properties. But it's, because we're in Python in an object-oriented language, these objects can be passed around like variables. So this object now exists within this list, and it could be treated, it could be all the properties and all the functions that that object has can be accessed on the actual instance. So does that make sense, or should I explain a little bit further? Mm-hmm. So we also could have created these objects on their own. So we could call this running category, and let's instantiate it as category running. And we can print this category, print running category. So if I go ahead and print this, we will let's see. Yeah, cool. It'll go ahead and print that category. If I call this like lettuce, I don't know, this store carries a lot of lettuce and it has its own category for it. If I go ahead and print this, it'll say no products available in lettuce. Yeah, and Ethan, we'll definitely create a products class and pass it into the categories class. But I actually kind of ran out of content for this part. That was actually going to be in part 2, because we're going to use a bit of a more complicated relationship that classes have to create all of our products. And I was going to spend quite a bit more time discussing that. But in the future, we definitely would add products into categories. But to sort of elaborate a little bit more about what these objects are. So actually, when you're creating an array in Python, or you're creating a dictionary or other things, those themselves are objects. So remember how if I were to create a some list, and I instantiate it with a bunch of random stuff, A, B, C, I could do things like sumList.append, sumList.clear, or delete, or things like that. All of the reason I'm able to do that is because Python has somewhere a thing called like a class list. It just it's storing it somewhere in its own code, and it knows that when you create this, it's sort of equivalent of calling list A, B, C. In fact, I think it's even possible to do that. I think we can even do that. Maybe not. Maybe I have to actually import it from somewhere. I know you can do that with dicts or something like that. But essentially, from somewhere in the code base, you should be able to actually import list and actually use it as an object. It just so happens that Python will do that automatically for you. Or maybe if I do lowercase list. That didn't crash, so that's possible that that's the case. Oh, at most one argument's got three. Oh yeah, it expects an actual list. Um, oh yeah, for sure. Actually, I'll make my font bigger. Sorry about that. Oh, cool. Is that better? Awesome. Yeah. So actually, just to show you guys just how kind of not crazy different built-in things in Python are compared to what we're writing, list right here is essentially a class. It's just lowercase, and that way Python knows that we're using the built-in list, and we're not trying to use some kind of special list class that we wrote. But as you can see, my VS Code, as I highlighted, even shows me the documentation. It says class list, and it expects an iterable. And that's actually how we can do things like list dot count, for example. All this is that someone, one of the developers of Python, wrote in the list class def count self, and they did a bunch of code to return length or something like that. I'm not sure what count does exactly. But and that's where all of these built-in functions come from. We're just creating our own class, and the convention in Python is when you create a new class, and pretty much the convention in almost every programming language, you define a class with a capital case letter. So here we have category, it's in capitals, and store is also in caps. If it wasn't, then you're sort of like the lowercase things are reserved for built-in classes. So you can do stir as well. Int technically is a class called integer. So as we can see over here, and it actually even, we can even see what it does. It's an integer, and it takes in an X, a number, and it even takes a optional parameter called base. So we can have like a base 16 number if we wanted, or a base 4 or base 2. We can use integers as binary in a way. Yeah. So when we create this this instance, this is now just a object, and we could treat it the same as a dictionary that we've created, or a list, or a string. We can just pass it around as a variable. It's just the type of the variable is category, and we defined that type. Instead of saying it's a string, it's specifically a new type called category. Any questions about that? We can even pass that as a variable here. Here we just implicitly define them. We didn't create separate variables. We just define them right there in the array. But here I can also pass a running category in by passing it as a variable from line 18. And when we create, another thing to add is when classes have other classes in them, so this store kind of has categories, we kind of define that relationship as class A has class B in it. So class store has many categories. So we can define this relationship as has many, has one. Yeah, definitely. I'll paste the whole code base in. Um, for sure, and I'll always make sure I paste all of the code that we write together in. Cool. Let me get rid of this. So knowing this can knowing these classes, what is a good, let's say, type of program, or how do we go about when we let's say the method that we used last week, to solve problems. The first part of it is to understand the problem. And in this case, how can we use that step of the method and the object-oriented programming, kind of how can we go ahead and combine and understand our problem using objects? So more specifically, kind of, I feel like I phrased that question a little bit weird, but essentially, when we go ahead and think about the problem at our hand, we can go ahead and come up with all of the different objects and their relationships. So we created a store, we created a category. We have a relationship between a store saying it has many categories. Those categories might have products, which will then have a many relationship from category to products and so forth. Brett, that's a good question. What are our nouns? If someone can answer. So we defined two classes, which are nouns. So in this case, what are they? Oh, Brett, you're right. That's a good point. You're right. But we might as well just go over it. So we have the store and category. Yeah, Layla, you got it. And what are the adjectives on the store? Yeah, we got name. Yeah, and we also got categories. Definitely. And what kind of nouns do we have, or verbs, sorry, that we have? Yeah, I guess we really only defined the stir. Another common thing in object-oriented programming is to also define getters and setters. So at this moment, we've been accessing categories and name directly by just going store.name, store.categories. And that's fine, but sometimes if we want to be safe, for example, and we want the ability to have kind of a private interface. So let's say we wanted to have the ability to change a store name, but we want to make sure that it fits some kind of approved regular expression. We don't usually want to just go ahead and do something like store.name equals something else. We might want to write a function called change name, new name. And maybe here we could do validate that the name is appropriate. And then if it's not, if it is, we can do self.name equals new name. And otherwise, we might be able to throw an error saying inappropriate. I'm not going to go ahead and add the validation, but we could basically do something like this. And another convention in Python is if we want to have a private variable that we tell developers not to access directly, we can add a underscore to it. And this sort of gives, it doesn't actually do anything technically, but it's a convention in Python so that when some other developer is using your store class, they know that the name shouldn't be accessed directly, and most likely there should be some kind of setter. So usually it would literally be called set and set name, and that tells developers that there is a approved method of changing these attributes, these adjectives, and usually it might be dangerous to just go ahead and change the variable because maybe you have logic around changing something that a developer might miss because they're automatically setting private variables. Yeah, Brett, exactly. It's not actually protected. There isn't really like a private versus public interface for classes in Python. Some other languages like C or C++ would have them. And actually JavaScript, the newest version, ES6, also has kind of an interface with private and public in a way, but neither of those languages out of the box actually ever cared about having a public versus private. Um, yeah, so it's just basically it's basically just part of Python culture. Any variable with an underscore to it, basically stay away from it. Don't read it. Don't write to it. Just be a good Samaritan. It's possible that some linters might even tell you, hey, this variable has an underscore to it. And you probably don't want to go ahead and set it. Actually, right here is what I need to have it. So actually, yeah, what's this? Oh, right. So here, I would maybe not be doing the best by accessing it. Maybe I'd want to do something like get name in this case. Yeah, there would usually be an so if there's an underscore, usually a method to change it if you want it to be changeable. So sometimes you might want to have private variables that technically no one should maybe know about. Um, and so it doesn't mean that you have to write setters and getters. It's only if you kind of want the ability for someone who is using your class to set it to anything. Sometimes you might want to define something right off the bat during the init process and then never change it. And in that way, it's kind of like a private variable that just the class object itself knows and might use in its functions, but the public doesn't have access to it. And like lists and dictionaries and those built-in classes in Python, you technically could take a look at their implementation and see what private methods they have, and you could read their private methods. Um, but but technically, they're not actually private. You could read them. Cool. So yeah, like I said, at this point, we've gone to this place where we've created two classes and we established a relationship between them. The relationship between them, when I say that, we're really just talking about, again, nothing technically technical, but in object-oriented programming, not only do we have these nouns, but we also have we have to think about how these nouns interact with each other and how they're related. So there are many different relationships, and in this case, we've created basically a ownership kind of relationship where a store has many categories. If we only defined it as self.category, and we said that this is like a very specific boutique that only does one thing, then in this case, we've created a sort of a has one category relationship instead of a has many relationship. But for us, that's again, when it's not a technical thing as much as it's part of the paradigm that we are discussing when we're implementing object-oriented programming, when we're creating these objects. And the power, of course, with this being that these objects become incredibly extensible when we want to create new versions or new copies of them from essentially what we could call a blueprint. Yeah, Brett. So exactly. So line 6 is where we actually have a list of instantiated classes of these categories. Yes. So there is the class category, but then there's the actual instance of it. So like when we talked about our car analogy, we had a class car, but when we actually want to create an instance, we might call it like a Honda Pilot, and we might create a specific instance of a car that has specific variables. So just like down here, we created a specific category called running, a specific category called basketball. They use the category blueprint to make this category, but they are all specific instances of a category. And Ashley, you asked, so the only way these two are connected is at the bottom. When you say bottom, do you mean this line that I'm looking at, 23? Mhm. Uh, yeah, I mean, technically, we could also do something like this. We could do my store.categories equals a whole new array. So let's say we're doing a rebrand. Again, we can go back to our grocery store analogy. So really, we're just setting a variable to something. So the let's call this dairy. So basically, categories is a list. It just happens to be a list of these instances of these objects called categories. So I guess technically the real relationship's defined up here. So, and now if I were to print this instead of it saying welcome to the department, the dugout, it'll say meat and dairy because we reset what categories is pointing to. And categories is just a list. So we could also do something like this. We could do dot append new category, category football. We could append it like that. Oops. Oh, I keep forgetting to save, my bad. Cool. And so now football is there as well. Because all categories really is just nothing more special than a list. And all of these really are is just variables that are instances of this class. Cool. Do you guys have any more questions about what we just created here? Line 16, we are getting the name for the category class, not, yes, exactly, right? So C in this case, we can name it a little bit better. We can call it for category. So this actually goes ahead and points to the individual instance of a category within this list of categories. If we wanted to access the store class, we would still have to do self dot name, because in this case, self is the instance of the store and categories is the array or list of instances of categories. Any questions about our input process and the while loop, and also how we go ahead and check user errors? Because as a hint, you guys will be creating a adventure game, and we'll go over that in a sec, where you will also want to ask users for input. Cool. Um, so basically that's pretty much it for going over classes for today. So what I'd like to do is just go over kind of this week's assignment with you guys, if you want, and we can talk about kind of what we learned today and how we could apply that to the project that you guys will be working on, which, as I said, will be kind of a text adventure game. If anyone's ever played those, essentially you have a game that is all command line based, and it's essentially kind of like a story where you get to navigate around different rooms and inspect them, and maybe potentially encounter either different items or different all kinds of objects. And it's a great example for object-oriented programming, because video games in general have a lot of different objects that you might want to create all the time. Think about some kind of enemy or some kind of room or some sort of item, right? You definitely want to keep creating these copies of objects, and so you can define video games very effectively with object-oriented programming. So I'm just going to drag this over here. I think you guys got I think I sent this link already for, yeah, for the project. So you guys can look this up there. Um, and for day one, what you want to do is first you guys have used REPL before? I'm not sure if I should go over that. Okay. Okay, cool. To be honest, you guys probably know REPL way better than me, so that's good. But essentially, we're gonna write it in REPL, and we want to create a command parser. So this is going to look very similar to our code. Let me zoom this in. It's going to look very similar to our code at the bottom of this file, where we have input and we have a while loop that keeps asking players for what it is that they want to do. And also want to make sure that we're validating the input and making sure our program doesn't crash because a user might input something that we don't want them to input. And then we also want to create two classes, one for a player and one for a room. And over here, we have all of the specification for what it is that we want the room and player to have. So much like our store, we want the room to be able to have a name and be able to have a description. So maybe we want to say this is the dark cave, or this is the second floor of a fancy hotel, or whatever kind of adventure we might want to have. And then we also point out that we want to have a couple of verbs. So it looks like rooms are going to be connected to each other in some way. And so when we write N2, S2, E2, W2, so essentially we want to go north, south, east, or west, we want to be able to show up to a different room with a different name and a different description. I see some writing, so I'm going to pause for a second for questions. How do we add a REPL parser to a file? I think, let's see. Oh, okay, I don't have access to REPL. I think what they're talking about is in REPL, it's kind of like an IDE, right? From my understanding, I think you just want to have a file called adv adv.py, and you'll basically be writing the loop that asks for input there. That's going to be your main file. That's what's going to be running, and you're going to import your room and player into it, if that makes sense. I think you guys can have files, right, in like a folder structure in REPL. REPL is a command line thing. Huh. Also, Ethan, yeah, kind of like app.js. Yeah. Yeah. Oh, okay. I think I'm just being, uh, hmm. Oh, I'm just being silly. Uh, I think you actually don't need to use REPL it. I believe I just realized that REPL stands for that command line interface that you would be writing in. So it's the Python interpreter. So when we're asking for input, that's what REPL is. Yeah, so uh, learning with you guys right now, REPL, read, evaluate, print, and loop. So essentially, we want to create a REPL parser in adv.py. So you should clone this repository and work from it, essentially, is now what we want to do. Cool. Um, So there's quite a few things in the specification. And also, by the way, Brett, you asked, also, yeah, you could do this in VS Code. Yeah, exactly. So forget everything that I said about REPL in that regard. But Brett, you asked, the different directions are methods, not attributes, right? Exactly. Yeah. So these are verbs. So we would want to actually create them as methods on the class themselves. Any idea, basically, so what we want to do is, I suppose, what should we return based on if someone calls, I'm in room one dot n2, what should n2 return? Yeah, Layla got it. So the room to the north, right? And Oliver, yeah, maybe I think N2 should probably actually just give you the room that's north of the room. You might want to have a function that lets you scout out what are the four rooms. That's probably more up to you because I don't think it's part of the spec. But if you want to do that as like some kind of player action or an action on the room itself, yeah. But yeah, also Brett has a good point. Find out if we can go north first. Maybe there is no room to go there. But definitely we want to return the room to the north. So we're already thinking that there is a relationship with one room and other rooms. So the classes themselves, the instances of classes, can have instances of other instances of class of room in them. Oh yeah, okay, you're right. Actually, okay, if Philip, if that's the case, yeah, then you're right. N2, S2, E2, and W2 are attributes. I should have literally read it right here. So yeah, okay. In that case, basically, I'm assuming when you want to instantiate a room, you might want to optionally give um, give other instances of rooms to these attributes. You're right. So there probably will be a function called move to, which would be the verb, and that could exist somewhere else. It could potentially exist in your REPL parser itself, because we also have this current room on a player. So this was kind of what we'll use to keep track of where the player is. And I think it's a pretty open-ended challenge as well. If you feel like there's verbs that you might want to add to rooms or players or create other classes, I don't see why you can't go ahead and just have fun with it and come up with different verbs that you might want to have. Um, I would say if they aren't passing as params, I would say that I personally don't see why you can't extend init. So if the code looks like this. Oh, I guess you guys have code here. I don't see any code. Right. I would say that you probably could put them in the init. I would say that it's possible that they don't have to be put in, so you might want to consider using them as optional variables, right? Because not every room might have a north room pointing to it, and not every room might have an east or whatever. Sorry, Philip, do you have a question? Uh, I don't know if that was what you wanted me to answer. Oh, okay, okay, cool. So they do it here. They manually set it. Um, I would say that it's also totally reasonable to have it as part of the init as well as optional params. Um, it, it's really up to you guys with this. So here's where you would probably keep track of where the player is currently, and you would also want to keep track of actually moving the player correctly to each spot. So you might want to have somewhere a verb called move to, for example, and it might want to check if that is a valid move, for example. I would say you could do that in either the loop or potentially in some kind of class. I'll leave that up to you guys to decide. It, either option, in my mind, seems reasonable. It's not like one is more correct than the other. And also on that topic, kind of how I thought about it, whether it's reasonable to have a move to just live inside the REPL loop or should live within some class. Usually, a function like move to manipulates your current state of the whole application, and in that case, those kind of types of functions generally could live outside of any class because they sort of manipulate the relationship between different instances of classes. But they don't necessarily need to exist on some kind of class themselves, if that makes sense. Usually, when you create a verb on a class, you want to just manipulate that class, that instance itself. But if you're manipulating relationships, you could write those functions outside of classes generally. Cool. So, and yeah, more shouts. All we talked about today's a bit of a shorter class. We don't have to go too much more into this. We went over uh, classes and how we can have classes within classes. Um, and you will also encounter setting attributes of classes to other instances of that same class, which again is totally reasonable. And as you can see in the source code, that's exactly what they do. So a room will point to another instance of a room. Also, make sure when you're linking rooms together that, unless you want it for your adventure, they're two-way connections. Yeah, for sure, I can go through the while loop again. Um, cool. This is our REPL for our application, right? So at first we have our read, and so much like everyone here, will also have an input, and the input might ask for a command to do, and there will be, yeah, totally, sure. I'll go over and add some of the notes in it after class to kind of give more context on all of this. But essentially, this is where we do our read user input. Um, and to put it in the REPL context, let me just get that. There we go. Evaluate the input. So when we want to evaluate the input, that's what we are doing with these if statements. So we only have a few valid things that we can input. We pretty much just have a number from range 1 to the length of our categories. For your game, there might be quite a bit more commands that you might want to add. So in that case, you can use a bunch of if statements. What's another kind of piece of code that we could use to structure kind of uh, that we could use to structure how we process one piece of input? Yeah, exactly, a switch. I was struggling really hard to say how do we not process different cases. Basically, this is a perfect use for a switch case as well, because you have five, six, maybe I don't know how many different cases. But again, at that point, if or else if and else's are also perfectly fine. Here, when we process the input, we first want to double check that it's a number, and if not, throw handle error. So then we also want to check that the selection, check if selection is the quit option. So we always have this quit option, which is just one number higher than what our length of categories is. Then we want to check if selection is within categories range. And then after that, if all else fails, give error message that it's not a valid input. So you might have checked that someone is doing the command for examining a room. Actually, Philip, that's a very good point. You're right. There isn't a switch. I've been programming a little too long in JavaScript, and I remember. You're right. Forget everything I said about switch. You definitely could use it if we were in a different language, but in Python, they realized why not just have a bunch of if-else statements, right? Um, yeah. So if all else fails, and here this is handle error for for non-number inputs. And the reason we could make this a while true, so this could be a while true, but we also want to first check. We set selection to 0 here, and we want to check that there actually is something in categories, because otherwise why even bother running the while loop itself? So if selection doesn't equal, so this would be, yeah, like we would want to exit the loop, but we also exit the loop right here as well with this break, which we could, if someone types in Q or something, yeah, exactly. While the selection is not quit, exactly. So if selection ended up being the quit, and we went through all of these, we'd get back up to here and we would terminate the loop. I'm going to write Brett's comment, while not quit. So here, you know what, we'll just add the comments right now. Instantiate a store instance. Cool. And we also kind of, once we write classes, we get the benefit again of being able to import them from other locations. And that way we can break up our code into very specific logical chunks. So when we're just coding categories, we don't have to modify this file at all. And it'll get all the benefits of category because we import the actual class right from this file, which you guys will also have to do. So you will have a room and player, and that way we can organize our code a lot more cleanly. Um, Okay, so I think we did go over everything that we pretty much need to go over for everyone to go ahead and start the day one MVP, so minimum viable product in this case. We went over how to create the REPL command parser, and essentially you'll have a line that'll input a while true loop and a bunch of if cases, if statements that checks for user input and does some specific manipulation to some array of rooms, for example, or a player. Um, and we discussed how we create these classes and some of the things that we might want each class to keep track of. And there is also no reason that you guys can't add your own verbs or your own adjectives to these classes if you want. If you want to personalize the player, you can go ahead and give them a name or some backstory, whatever classes. If you guys really want to go far and make some kind of RPG game or anything like that. Um, but in terms of just the base things, we pretty much have everything we need for that. And then for day two, we will go ahead and describe useful ways of how we can create items, and we'll discuss how we create products um, in our store store app, and we'll talk about different ways that classes can relate to each other besides the just storing each other as variables. Cool. So any more questions about anything? Great. Okay, so I will share this code that we wrote, both for store and category. And I think best of luck with everything. Instructor hours are Wednesday. Yes, they are Wednesday, and I believe this week you guys will have also. You should, yeah. I think you will have. No, I don't think you will have any of the. Oh no, maybe you will have whiteboarding. That's Wednesday, right? No, instructor hours Thursday. Sorry, my bad. So we'll definitely have a lot of time to go over the actual project once we go through all the two parts. Cool. Have a good night, everyone, and I'll see you in a few days.